Good morning, everybody. Thanks for coming. Hopefully there's more that will pop in. My name's Andre. I work with Yusuf M and K. Tim has been a large part of the Docker community in South Africa. He's one of the listed captains and so forth. He's going to spend some time with us today, taking us through the basics to intermediate Q&A and so forth. Right, so I'm going to hand over to Tim. Enjoy.
Hi everyone. Part of my thing is here, I'm also going to be working on where you guys are and stuff like that with Docker. Problem is, how do you use it? Well, it depends on where you are, what you're doing, what other programs you have. I'm also not sure exactly where you are, but what we're going to be doing today is basically finding out where you are with Docker. I'm going to go an intro over Docker again. So my previous experience with this is there's always a couple people in the audience who don't quite know what the advantage of Docker is. But it's also leading into later on with what are the best ways to use it. Because knowing why it's good and what it actually solves actually helps you then use it to deploy better. And then I'll go through some demos of some of the ways I recommend people. Like they're the starting process of using Docker to deploy live and test and all the rest of it. You'll then use that. There's far more expansions that you can go on with this stuff that makes it easier. Just who I am, 15 years developer, DevOps. I'm a Docker captain for my sins of playing with Docker. Basically, it's community outreach, so I fortunately get access to some of the Docker engineers on Slack and stuff like that, especially with the new Swarm stuff. It's actually been very cool. I might show you guys a demo unrelated to the talk after this, what the new Swarm can actually do. I don't get anything out of this. This is just something I love playing with, just in case you're wondering why I do this. Okay, quick survey. Sorry? Awesome. Okay, Windows, Mac out here. What do you guys use?
Both.
Both. Okay, so server OS, I'm assuming Linux or CentOS or Red Hat, I'm assuming? Or
Some FreeBSD also.
A bit of BSD, okay, cool. Unfortunately, it doesn't run on BSD, but over there with the jails, which works very similarly to this. BSD had it first. I'm just going to say that. Unfortunately, Docker's outpaced the development on that side. More on the user friendliness and how to interact with it more than actual power. Though apparently Docker is working on making how you work with their stuff work with BSD and later on with Windows. I keep on hearing that it's going to come out. I have no idea when. Also, I'm not that interested in Windows containerization.
So just for FreeBSD, they did a port last year.
Okay, so they actually do that.
It works 90%. It just didn't work with DC hosts, so we had some DNS issues, but it worked. So
yeah. Like I know they're doing a lot of work and stuff. I know on the larger IBM stuff, I can't think what their stuff is underneath, but like the big stuff that's not, yeah, that stuff, they've got guys using Docker on that. I did a talk at Midrand, Johannesburg, and the guys were telling me about it. How much of you guys, have Docker, how much beginner experience? Let's say no experience with Docker. Okay. Beginner experience with Docker, you've done your first run. Okay. Intermediate, you've now actually maybe deployed something live onto servers. Anyone here? Yeah. Okay. Next levels is you've been playing with Swarm and networking and that type of stuff. Cool. I'm going to show you the Swarm stuff after this. It's very cool. All right. Okay. So you guys all heard about Docker. I assume that's why you asked me here. I've heard it's great, but why? Pretty much the big thing Docker adds, like you're going to hear a whole bunch of other things. The really big thing it adds is this word that you can hear in IT a lot called immutability. And what that gives you, it basically means, it gives you predictability, is I can have something that is the same everywhere, that it doesn't change. You're going to hear about this if you guys play with web development, that why React is so great is because you can do immutable stuff. Why is Puppet, Chef, Ansible great? It gives you some of that immutability. I create something, and when I give it to you, like it's all the same. And that is what gives you the predictability. So when I test it, I know that it's the same everywhere. Now, that gives you that repeatability of servers and dev. So now I have the same image that the server has, and we're both deving on the same image. So when I'm missing a library, you're missing a library. When you have the library and I add something to it, everyone then has the library. I'm sure how many guys have devved on their own PC and you quickly needed to add some library, you added it and you deploy live, or you give it to other guys, and then they all bitch at you. Because why did you break my system? And then you spend however long going through to everyone's PC busy fixing their libraries that they have to get it to work the same way as yours does, and then try to work to do that on the server. Or the other one is, okay, cool, deploy to this server, it worked fine, now deploy to the other server, oh wait, there's a library missing, or the library's on a slightly different version. Like, that is nice time when things like break related and stuff, those are the problems. This is the big thing that Docker solves, is because you basically contain all the libraries and PHP version, everything is static except effectively, and you have a way of now deploying that image around, you get that predictability. It makes, like, okay, when you guys bring in new guys, I'm sure you help them set up his new PC, right? How long does that take? I imagine, like, you know, I've had it where it can take a day or two to just get all the tools that the guy needs to be able to do the builds. You know, I've implemented this before when I was at AfriHost. It's down to an hour or two, just how long it takes to install Docker and all the rest of it. And then they've got the full wall chain. Look, they've just got to work out how all the pieces work, but it's not like get MySQL installed, get this specific version, get this thing, your direction must look like that. Which effectively removes the, yeah, but it worked on my PC. Or works on my server, why is it broken on your PC? We've all done that. It's like, I don't know why it's broken, and then eventually track it down to something like that. The difference between dev and prod decreases dramatically. This is also a big headache between those two. Like, on your PC, you'll be running PHP. Like, I'm using PHP as an example. It's the one I've had the most, but it's the one where a lot of people have this pain off. Node is another example. I'm running Node 6.3.1. Why is this breaking on the server that's running Node 0.10? Look, this is within reason. Like, there are certain things you can't magically replicate everywhere. Your database is one of those examples. Right? If it's a live database, it's normally too big to replicate to all your dev servers. If you are working on your dev server and I make changes to my database, well, that's mutable, your database will look different. You know, this is, but these problems here are the problems you have with everything anyway. Just more to be aware, it doesn't solve this problem. It solves it around this problem. Gives you, because you're now immutable, you can version it. So you've got an image, right, which you tag. You say, this is version image 5. So when we're testing at version image 5, and then we deploy version image 5 to the servers for live, it's the same image. Once again, this is the whole immutability. It's a guarantee of the same. You know, like people always say, like, when something breaks, you actually want it to break every week. You want it to break the same way every week. Everyone's going to know that all things break. It's like, yes, but then you find the problem. It's not broken on this server on the 5th day of June, which, you know, quietly these errors are creeping into your system, and those are very hard problems then to solve. If it breaks on everyone's PC, hopefully in dev first, which now you've increased the probability, you've now decreased, you've made it easier to find the problem, because everyone should be experiencing the same problem. You can also now roll back. You versioned it, right? So who's upgraded a server, something breaks? How do you roll back? Or you reinstall the server or something like that. Or if you're VMware, like if you've got virtualization, you have some of these tools, but this gives it a much faster, far easier. Basically, you stop that image, you start the previous image because it's tagged. Just to give you an example of startup times for running a container, you know, it's a couple seconds. If you had to restart and roll back a VMware image and then come back, you know, you're talking about quite a bit of time in that. First of all, it's also then finding, because, you know, quite a lot of people haven't versioned the images and stuff like that. With Docker, it's almost built into the system of doing this. Because of how it works, pretty much the time it takes to restart whatever application is running in that Docker container is how long it takes to start. So how long does it take to restart Apache? You know, it's a couple seconds. Now, because you've got version, your test process, so from dev to test to live, becomes a lot easier because you just move the same version. I'm going to talk about that a bit more. I tend to re-tag or add an extra tag once it goes through each stage. Just helps me track where everything is. Some bonus stuff that this stuff gives. Okay, running 5 containers is significantly cheaper than running 5 virtual servers. You know, as soon as you start up a virtual server, you immediately lose about 512 megs of RAM, whatever CPU is not there, but you also lose some CPU of the systems and processes running in the back. When you use this, you have the cost of whatever's running in there. Look, yes, if you run 10 Apaches to do 10 vhosts compared to running 1 Apache with 10 vhosts, the 1 Apache is cheaper. You can do that in Docker, but just as an example where it doesn't always go, but you're not incurring the cost of the whole VM server every single time. So like if you're running a VM server, you've lost RAM running the base, whatever you're underneath, VMware, OpenStack, whatever you guys are running, and then you run the virtualized server. And so, you know, immediately you've got a meg and a half gone just to run a single server. Now you've still got maybe the meg gone, or half a meg, but the cost after that, you've just got the cost of the patching. It reduces that quite a bit. Also means moving the stuff around or starting up lots of them is actually quite cheap.
So just a question, when you're saying instead of using a hypervisor, you're running Docker native on a blade or physical server, are you using something like CoreOS or what are you using?
Personally, I just use straight Ubuntu and then install on there. The main reason with that is I've had a lot of experience with that. So I know that one well. So when it breaks, I know how to fix it very quickly, very easily. So
I love CoreOS.
I've looked at a bit of play with it. It doesn't add anything to my life. Look, the things that they sort of add is sort of rolling updates and all the rest of it, which is pretty cool, pretty nice. Your big difference now, I'm not sure if it breaks that I can fix it.
Because I tried out Swarm in the first keyboard.
Yeah, no, like that's the big thing. I'm going to show you maybe I'll do the demo anyway. It wasn't going to be part of my talk, but I'll do the demo of the new Swarm. The old Swarm was a mission to set up. It's like, you know, a couple pages. I'm going to show you just how horribly easy it is now. They've just released 1.12. In that, they've basically incorporated Swarm into Docker. I'll show you, it's like really scary how easy it is now to do it.
First trials, I can hold it back. So
Yeah.
always feet.
Yeah. Look, those are, in my head, is learn Docker first. Learn how Docker works on whichever server you're comfortable with, which it is. Your thing is try to get a newer kernel of that, so if you're running 6.6 or 6.7, don't just jump up to some highers. You get some more features, and 6.6 is still, you know, they backported a whole bunch of stuff in, so it's not, it works, and I've run stuff live on that, but you're just going to make your lives easier going to the newer stuff. Once you've solved that and you understand how Docker works, then start playing with the other ones to solve some of your other problems. So, like the networking thing that CoreOS does solve with Fleet. Flannel, sorry, yeah, get the F's and all that. Swarm now also solves with encryption and a whole bunch of other things. Look, the big problem still in Docker, the one thing that Docker doesn't solve is the replication of file system. So there's some other tools that you can look at for that. We'll go over some more of that stuff later. But also with you guys, if you guys are wondering about anything or have any questions, stop me now. I'd rather you stop me and I actually answer the questions you have about Docker than I just sit up here and talk and you guys don't actually get understanding of it. Sure, go.
Do you run Postgres in MySQL?
I do. Obviously mounting with the volume. Yeah. The databases is the one thing I oscillate on whether you should do it or not. Like especially once you start hitting the larger sizes. Generally you're going to have a server to itself. Like, so then why are you adding Docker? Like, you know, you're adding up complexity. What is nice now is you get the versioning of the libraries, which can help, so you can roll backwards and forwards, but like databases are a different beast. You know, they tend to, you know, using all the RAM, there's nothing else you're running on. I'm talking once you're hitting larger sizes. Yeah, like where you might use Docker there is for simplicity of deployment. So you can pre-test clustering stuff in deployment and then maybe use it there because you can then, you know, write scripts to automate that stuff. That's where I might use Docker, just because then, you know, it produces the whole bus factor. Like you're away on holiday and Yusuf wants to quickly spin up his own MySQL cluster, but now it's in Docker and you've scripted it. That's the time where it does solve you things. If you're just going to do it and not be changing it, it's a grey area. Like, until you know Docker well, just stay away from databases in Docker. The databases that do work well in Docker, though, are your cloud NoSQL replicated ones. So Mongo works really nicely in there. Elasticsearch, Redis, it does. You just got to, it's in memory. Normally with Redis, my theory is, if you're storing anything in Reddit that you can't throw away, you're doing it wrong. It's like a general rule for. Sorry, I've tried to hammer that into people because
it makes it to disk every now and then.
Yeah. Well, you are replicating to disk, but the whole thing about Redis is it's supposed to be a high-speed cache. You are replicating disk, but you're not treating it the same way you're treating normally your MySQL. Or with replication, where yes, you can run clusters of them, and it does, but that's more about you don't want to suddenly lose half your cache when you need the cache, because suddenly you lose the cache and your servers can no longer handle the load and amount. That's normally why you have more of them. With my head is look, depending on what you're using, there's always exceptions to this. But for how most companies use Redis needs to be treated as volatile. And how I eventually solved this where is every now and again I would remove that Redis and spin up another one so that the guys were used to, why did my stuff break? It's like, well, why are you storing information you can't retrieve out of the database inside Redis? Because that's how you should be using it. It's a good thing to do because that's the thing, is the next thing you need to take a Redis out. And we had it once or twice where it accidentally happened and then a whole bunch of things melted. And that's when I started doing this reboot thing every now and again, not persisting to disk. Because there were multiple, so another one would immediately take over. So caching was doing, and it was partitioned, so you wouldn't lose your whole cache. So it didn't cause slowdowns, but it stopped people using it quickly. If you're using it as your main store, you've got to think very carefully about that. You can do it, it's all done, it's an exception. You can use the in-memory MySQL. Let's just quickly move all our databases to that. There's reasons when you want to use it sometimes.
Okay, so last one.
Yeah, sorry.
What are you using to deploy Docker? Are you using something like Chef, Ansible, Puppet, or?
I'm now actually using Docker Machine. I'm not working in larger teams now, so for me that's better. I'll show you why. For a larger team like you guys are, Ansible, Puppet, Chef, any of those would be better. The main reason with Docker Machine is I get a key exchange, which means I can then speak to them all directly from my PC. So that the login to the registries and stuff sits on my PC, doesn't sit on the servers, and I can then control everything from that. There are ways of then doing the key thing with multiple people, but it's a bit harder, so it's not always able. I'll show you some of that stuff at the end. Okay, just coming to how Docker's achieving alpha. Basically, Docker underneath isn't doing that much new. Like you said, BSD-JAWs have it. All the stuff Docker's doing, it is a wrapper that makes it easy to do this stuff. Basically, it uses something called namespacing, which the kernel has. What that is, and this is a big thing in Docker, is how you're actually getting the isolation is at namespaces. This pretty much puts your networking and your process that you're running and the file system into a separate namespace. You guys ever done any CH roots or anything like that? It's the same concept. Basically, it goes into a private area. So once they're in there, they can only see the same things that are on the same namespace. So the files that they can see are only their files. The files that the networking they can see is only their networking. Everything's the same. So if you go PSOL to start a Docker thing, you only see your processes. The external server can actually look in and see more, and there are ways of entering those namespaces. Before it was a bit of a mission, but now inside Docker they've got a whole bunch of stuff to do that. But basically that's how it's working. So you've actually created a separate namespace that add a networking card in, they add basically some file storage in there. The file storage is doing a whole bunch of fancy stuff, but that's just an add-on, it's a bonus that Docker adds. And now it's in a separate process. They then actually connect this networking thing into a bridge and then do IP tables routing to get it out. So if you've been playing with Linux and you actually start looking at this stuff, look, the namespacing stuff is a bit more advanced, but underneath it all, it's actually just learning IP tables and routing and a whole bunch of very simple things. It looks a lot more complicated on the outside, but what they've done is they've made it very easy to use all these things. Second thing was the concept of images. And this is basically, I can now build an image. So I have a script that builds my image, I then save the image, I put it in my registry, you then pull the image, you have the same image. Okay, that's one of the big things. It's not very small, but like once again, the repeatability of it. And those images have all my libraries in it. It's the same versions, it's the same thing, I can version it. The last thing they added was something called a Docker file. Now this is basically a way of scripting of building the images. If you ever install anything on a server in Linux, you can build a Docker file. They're horribly, horribly easy to use. It's pretty much as, I start from my base, which is on like Ubuntu or CentOS. I want you to now run these commands, which is your install commands. I want you to add these files, and these ports are going to become available. Okay, you now know basically how to build a Docker file. It's pretty much, that's it. The last one is you have to allow what command to run anyway. Now, once again, I can commit my Docker file. I now have a history and what exactly, how do I build these things. So this comes back to when would I use Docker for MySQL? It's because now I can unscript these things. Like, if you guys have used Puppet Chef or Ansible or any of these things, you know, they get quite verbose, they get quite long. Docker files are so much easier to use. Like, they're very, very quick, and I find a lot far easier to even use and run and stuff. They're a bit more predictable. And when they fail, that's fine, but you still have your old image. You haven't broken your server. The last thing is a registry. Basically, this is a central place to store images. It's where you can tag, version. This is the bit most people actually forget or aren't aware they should be doing. This is like, when anyone using this stuff, setting up your own registry or using an external registry is one of the first things you should do if you're implementing a larger team like this. This is what gives you the repeatability. I don't know, I've had it a couple of times where we talk about Docker guys, they've gone and it's like, but it's breaking on this guy's PC. Then I find out each of them are individually building the Docker file for the image on their own PC, which means this guy did it 2 months later and suddenly he's got different libraries and now it's breaking. Like implementing a registry, I'm going to actually put the code up how to implement your own registry. It's a lot easier than you think it is. You can also, get one of the external guys that works compile. Your team is big enough, I would recommend just running your own registry. In smaller teams, I'd say just the cost for development time, it's like, don't run your own Git, don't run your own email. It's going to cost you a lot more. For this size, registry is very easy to run. Okay, I just added the slide just quickly just to bring back into what the difference between VM and all the rest of it is. So on your guys' right, you've got the hypervisor, so you can see you've already got the hypervisor, you've got the guess OS that you're replicating, so it just visually shows you where all the memory and stuff is going. And on the right, left is the Docker stuff, so you can see there's a whole bunch of fewer pieces, that's why you get the same as of memory and speed. What doesn't Docker do for you? Okay, it doesn't enforce the immutability. If you want to do something stupid, it will let you do something stupid. You want to build images on everyone's individual PC and on the servers by themselves so that, you can't guarantee that you have the same libraries or speak. Like this guy built it 2 months later, which means he has a newer version of MySQL or whatever. It will let you do that. It's not going to enforce that. It helps you do the immutability, but it's not going to enforce it. So you've got to actually put 1 or 2 bits of process in it. It makes it very, very easy to do the immutability. In actual fact, if you're doing it correctly, Docker is a lot easier to use than every single developer doing the build on their own PC. But a lot of guys aren't aware of that registry and how to do it. So that's why I'm just mentioning it. Won't enforce it and so on. You can also go in and manually spin up, do a run on a Ubuntu and then start manually installing stuff without a Docker file and save them and push it to the registry. But then 2 months later when you need to rebuild it, what the hell did I write? Okay, so to use the Docker files, use the registry. It's going to take, once you've worked it out, everyone thinks it's going to be hard, it's really, really not hard. Once you've got that in, a whole bunch of pains go away.
There is even an official registry image from Docker.
Yeah, that's why I've got the command to how to run it and everything. I'm going to show you all you need to do that. I've got the command on one slide. Okay, sorry. So what happens? Okay, scaling. Right, scaling is a hard problem. What it means for every single company is something different. Docker doesn't magically solve the scaling. Like I've had a couple of guys who say, oh, but I have a cluster of Docker servers, so I can all treat them as a server with multiple CPUs. No. A lot of the problems that you have are the same problems. It has tools to help it, how to spin things up, spin things down, which is a hard problem in scaling. But now having 3 MySQLs, well, how they're replicating, how they're doing that. Those are the problems you're still going to have to solve in all these things. I'm not talking that much, but like if you start looking at things like Mesos and some of the other things, the guys have written scripts to do that, but that's built on top of Docker. Docker itself doesn't solve that problem, but you should have been solving those problems anyway. So you're going to solve those problems the same way that you did before. Mainly, scaling, if you guys have done it, it's hard. Like having, oddly enough, spinning up 5 web front ends speaking to a single database is fairly simple in Docker, but you still got a single database. Now I want to suddenly replicate the database. It gets hard. At some point, even that scaling of just spinning up new interfaces becomes hard because now my database server won't handle it. So you start adding things like Redis and maybe a DB that scales better. Like these problems are never solved for you. It's Uber. Let's switch from Postgres to MySQL. Let's switch from MySQL to running our own NoSQL on top of MySQL. Like as people scale, the problems just change. Having said that, in this country, there are very, very few companies that need to do the scaling the guys overseas do. Like our problems are a lot easier and a lot smaller. We don't always have the skills, and that's where part of the problem is. But like, we don't need to run 1,000 cluster of anything. I wish we did. It'd be awesome. I would love to work with some of those problems, but we tend not to have that as a problem as much as the country. Okay, this is the big thing that people keep asking about. Docker doesn't solve this for you. Apparently, they are working on something. When I hear more, I will let people know. They happen to just randomly mention it when they're releasing the 1.12 stuff. But when they did mention that this might come out soon or it might come out later, they're going to want to solve it properly. This is basically, I have a 3-node cluster. I then write some files to node 1. The files aren't visible on node 2. Okay. Docker doesn't solve that problem. There are tools that you can use to do this. It's the one. Oh yeah, there's NFS, but I'm saying there's actually ones that will do the replication for you. I'll remember the one, but like you can also run GlassFS, Ceph. The one I'm looking at now to play with is something called LizardFS. Apparently it's a bit easier and it's got a nice throughput cluster. Ceph is my favorite, but apparently it's a lot harder to set up. And there are actually volume plugins that will plug into Ceph and cluster. LizardFS I'm just going to use as a file system that if I write to this mount point on any server, it's the same place. To me that was just a lot simpler. And that's if you're a smaller team that becomes easier to use. But on your guys' side, Ceph might be a better option. But once again, a lot more complicated. If you don't have time, look at the LizardFS. If you look at it, I think the company might be, I don't know what the company is. It's a off branch of another open source. It's an open source product. All 3 of those that I mentioned are open source products. Look, you can go and buy proprietary storage hardware that does your replication and you mount a share. They will also solve it. And it solves it as well as all these others. The difference with these others, you're using commodity hardware to do your replication. So in the long run, it becomes a lot cheaper. If you need to do something really quickly, go to one of your storage guys that gives you something that clusters across 4 storage devices or the rest of it, and just do a mount. You'll be up and running far quicker. You still don't need to think that if this server is writing to the mount drive to directory 1, this server must also be writing to directory 1 or you're otherwise going to be overwriting. But when you start using the clustering stuff and you have a node die and start up again, you want it to then still be able to write to the same data. So let's say you do the Postgres thing, and you write to your shared storage, and now you migrate that Postgres to another one. You still want it to be able to write the same storage. You can do that. Effectively, all of this is using something with network storage to do that. This is the whole thing. Your DB still needs to be replicated. Far easier is just to use standard replication. This is why the Mongos are quite nice. Replicating in Mongo is horrible. It's fun. You bring a new server in, it replicates, you kill the other server, you throw it away.
Would you say that it's better to keep your database databases as a separate entity for now?
For now, I'll keep them separate. Like with all these things, just start with your application first. That's a very easy thing to use Docker. Learn all the pain points, learn the patterns. Then at that point, you either know whether you should do the database or not. Like, do not start with databases. Like, databases are complicated things. Having said that, there is a very, very minimal speed difference using Docker. Guys tested it and it's effectively negligible. So it's not a problem of, like, now I run my database in a VM, so you lose 30% of my CPU. That's not the cost with Docker. It's just more. I've had guys that do it and accidentally they delete the Docker server thing that they've just run up and they suddenly lose their whole database. You want to solve all those problems first. But this is all thing. If you're using Docker correctly, you can do your setup a lot faster, develop a lot faster, deploy a lot faster, and recover a lot faster. This whole CI movement, Docker almost fits perfectly into that. So if you're doing the whole, I commit to code, then I build the image for testing, I deploy it to testing, then once the testing's okay, I deploy it to live. Docker fits beautifully in that. Most of the CI guys that you see out there that are doing this service, they're using Docker, just because, you know, to throw away and have a clean system without any previous contamination from previous builds. Like Docker is, okay, stop, remove the old one, run a new one. It comes up with a clean, replicate exactly the same files as you had before. But once you stop it really does make it a lot easier.
So what is your thoughts about the base images? Do you build your own base images or you just pull them from?
It depends. I would recommend you don't start there. Don't start building your base images. Well, it depends what you mean by base image.
So like from Ubuntu?
Yeah, I would start with, pick whichever one you know the best. So CentOS or Ubuntu. Those are the two big ones. Pick one of those two, build your images from that. I'm using Alpine Linux a lot when I can, and that's because it gives me a smaller image with fewer moving pieces, which means
so
my...
You're doing a dev bootstrap and creating your own base image.
Yeah, just once again, solve all the other problems first. Once you've solved all those, if you're having problems with that, then solve that. But once again, you'll know why. Very, very few people, even the big guys, need to do that. Yeah, look, you can do it if you're paranoid. With the new registry and stuff, they sign this stuff. It's built by Ubuntu. Do you use the Ubuntu VMware image? Okay, you guys don't do cloud stuff that much. If you're on cloud, like everyone uses it, fairly. Look, if you really are that paranoid, you can build it yourself. It's not hard to do it. I think you're going to be adding a lot of, like with all these things, you only want to learn one thing at a time if you can, because otherwise you're going to get overwhelmed and it's going to take you 4 or 5 times longer to learn. And that's the main thing. You want to reduce the things you're learning and then add the next piece and the next piece and the next piece. And that's how you get really good at something, because now it all ties in together and your brain works better that way. Where you walk in and you're trying to solve Docker and build your own image and do databases and do this, and there's also clustering and networking on top of that, you're going to crack. It's just too much to absorb. You know, let's quickly all go. Imagine none of us knew networking, and we all suddenly came in and said, let's all learn networking and CentOS.
It's exactly what happened to you. So I knew like Galaxy, zones, and jails. Okay, try everything out.
Now that's the thing. It's like something. If you step back and just start with the run, build your first image, play with that. You suddenly realize that's easy, but now your brain has learned that. Then you step to the next piece and add the next piece. You can actually learn significantly what your learning time. Look, I tend to dive ahead first and then work myself up. And then I step back and try something. But yeah.
So, what tools do you have to manage the life cycle of an image? So, like, how do you avoid having hundreds of it running, taking too much resources, having it run the wrong version?
How do you avoid running too many patches? How do you avoid running too many virtual servers?
So are you talking about the whole capacity management?
Yeah, well,
Yeah.
I'm just saying it's so easy to
Container sprawl.
Yeah.
spin up something and stop
What
it.
I mean is, Docker, you come back to, you've got to manage some of the stuff yourself. So generally, now you're talking about the scaling, so now I've got clusters of stuff like this. If you use the Kubernetes or the Mesos or to think, a lot of that gets done, well, not done for you, but you get a lot of reporting. And then from that, you just got to decide. You can spin up you've got to manage your resources. You only have so many servers. Unfortunately, at a certain point, a human needs to be involved. You can write rules, but if you suddenly get hammered by 1,000 people, you don't want to suddenly have a rule that says stop adding new front ends. You want to have a user go, okay, let's scale back our data processing in the background and scale up our front ends. You want to have some of that, and unfortunately that's tooling you have to build. Once again, because how your system works is only one set of people who know that, and that's you guys, unfortunately. So people can abstract a certain amount of stuff, but not everything.
So you have to use other tools to manage.
Yeah, to a point. You might have to build, to do it is very easy, but you might have to build one or two of those tools yourself. It's not like you can do most of the stuff you can actually do in a day or two.
Just to add to what Tim is saying, so there's a whole bunch of monitoring tools that are out for Docker. It's like CFhunter and several others. So you've got to monitor your containers as well as your OS to know when
Part of it's the same as how do you know when you should scale up your server for your database? You've got to be monitoring. And unfortunately, not everything's quite magical. If you start hitting the cloud stuff, you can get a bit more. When people automate things too much, next thing they start getting $1 million bills because everything's scaled up too far. Over time, you'll work out these things. Unfortunately, it's one of those you have to work out for yourself. It's not quite there yet, but I don't think it'll ever be there because I like having lots of front ends because my stuff is very front end heavy. You guys like having databases because you do a lot more processing. The tooling though is improving at a scary rate. There's TGIF that the other one that everyone's now using is Prometheus. You can tie the two together. But it gives you just front ends on how many servers, what servers are running, what's the RAM usage, what's the CPU usage. With the new clustering ones, there's stuff that says I want 5 of these running and 1 dies to auto restart it for you. All the clustering stuff, all that gets done for you. Just knowing that you need 5 though, unfortunately at the end of the day you've got to work out. Scaling up some technology, this trips a lot of people up. If you're talking about an image, you're talking about the thing you build and you store in the registry and you download. Once you instantiate it, to use some programming terms, so think class and object. I have the class, once instantiated the object, that's called the container. So you'll hear a lot of people call about the running container. Containers are still slightly immutable. Images are not immutable. That's your CD. You then say, I now want to run this image, and then you call it a container. Just if you start using that terminology, it solves a whole bunch of what weird things is. When people talk about containers, you know where in the life cycle they are. And a lot of my talking, I've had a confusion about this where people get confused. Okay, this is just the basic intro to Docker. Any questions here?
What's your take on Prometheus? Are you using that for monitoring and stuff?
I've looked at it. I'm going to be a bit overly busy for the past couple of months, so I haven't had time to deploy it. It looks good. I've been hearing very, very good things. I've been reading about it. Is definitely the right choice right now. It's guys basically it was written for Kubernetes, and they've now ported it to all the other ones. So just to give you some background, Kubernetes is something produced by Google. It uses Docker underneath, and it follows how the Borg stuff works underneath to a point. But they've open sourced it. If you go and use Docker on Google Cloud, you'll be using Kubernetes. Otherwise, you can. It's an open source project. You can download it and implement it. It is more complicated. It adds more things. I wouldn't start there once again, because once again you're going to overload what you need to know. But it's looking very good. Just in this place, the other one to look at is something called Mesos. If you guys are a Java-heavy company, use Mesos. If you're not, use Kubernetes. I think in the long run, Kubernetes is going to win. But it's that might just be because I'm not a Java-heavy person. So Mesos comes out of, I think it's Twitter, that they've done it. And it originally didn't include Docker inside. They're now using Docker underneath for all the stuff. But that's your clustering. It gives you a GUI of what's running where, and you can stuff like things to say. I want to replicate MySQL, and do backups into Hadoop, so that when you lose your MySQL and you now need to restore it, pulls out of Hadoops, and now the Hadoops that distributes file storage that you have. It does all that kind of stuff things. But once again, because of that, you have a lot more complexity in it.
Also, Prometheus came from Google's Outline.
Yeah, from Kubernetes there.
So just talking about Prometheus, you're saying Kubernetes is Borg from Google,
Yeah.
and Prometheus is actually Borg 1.
Oh, okay. I wasn't aware of that.
So there was a couple of engineers that started SoundCloud. It's Google guys.
Prometheus. Look, it looks very nice, I must say, all of them. And like a lot of the dev chats, all the guys seem to be have switched to Prometheus, which tells me that if you're going to switch, you're monitoring it, there's a good reason. And I think it does tie into C-Advisor as well. I think it ties into C-Advisor. You can send backwards and forwards. Alright.
One more question. Alpine, what is that based on? Is that Debian based or?
Nothing. It's its
Nothing.
own Linux distribution.
Okay.
It's very, very tiny.
Does it have a bash shell at least?
No,
It comes with
it has Ash. You can install Bash if you want, but it has something called Ash, which gets very confusing because every now and again I want to exec into a kind of thing, and then it's like, damn, Bash shouldn't work. It's an Alpine Linux.
when you get this one binary that's got all of the tools in it, it gives you LS, it's like Bernoulli tools.
Yeah, I mainly use it to build some of my small. Look, if I can use Alpine Linux, I use Alpine Linux, and that is the difference because I can land up with a 50 meg image and not a 350 meg image, which generally isn't always a problem. But like if you're trying to pull a new version down very quickly, that's when you start to notice it. Generally, it's not a high cost to pull these images. Remember that you've got the whole layering thing, which I haven't talked about because it confuses everyone. So Docker images have layers in them. Now let's say your base layer is Ubuntu. If I already have that same layer on the server, it will only pull the top layer, so that actually is not small. Having said that, even with that, Alpine Linux still pulls faster than that because they aim for smallness. Actually, was designed originally for embedded systems.
Oh.
And that's where it comes from. Having said that, they use a weird version of C, and you've then got to be aware. So you've got to add some stuff. So once again, play with it, don't start there. Like, you're going to confuse yourself and things are going to break because of other reasons. I'm generally using it for all my stuff, so
it's called BusyBox.
BusyBox, okay. It's usually on the modems and routers and stuff, right?
It's like one binary that gives you LS chunk.
Yeah. Okay, BusyBox.
yeah, that's an image.
There's an outline like that.
It's slightly different. You actually get a bit more than that. I've played with BusyBox. So generally, if you're gonna, let's say, compile your own binaries, let's say you're gonna use Go.
Yeah.
BusyBox, or you can even actually go even smaller than that. I've got seen guys where, because they're compiling, like one thing about Go is it contains everything you need. There are no external dependencies. You don't need any libraries, or the SSL library is built into that binary. Which in old days you want to do because of size limitations. You wanted to share as much as you could. When nowadays, like space, who worries about space nowadays about the binary installs? No one.
The main thing is like the image needs to be as tiny as possible.
Yeah.
Because you know apps on it, that's going to be as small as possible.
Well, not quite. It's fast to deploy. It's easier to deploy. That's the main thing. It's not going to load in memory or anything like that. Because remember, you don't load really fast in memory. As an example, the etc.d. Now that's like a very simplified distributed key store. So if you guys have played with Zookeeper, it fulfills the same niche. So you get etc.d and console, the two alternatives. I prefer those because there's only one binary that's got a lot fewer moving pieces. It's 22 megs, the last version of it, for the image. So you can pull it to your servers very, very quickly.
Sure.
And they've got a Go binary underneath, and they just basically add the binary. Though you're now looking at the more complicated level of things. So you can start looking. I wouldn't start there. You're going to confuse. Start with what you know. You know Ubuntu. You know this. The cost isn't high. Like once you further on, you'll know why you want to do it. Okay, this is first bit was more of an intro. This is now it's a bit smaller. This one I want more questions about. So because this one you guys are going to need a bit more. This is sort of my recommendations of the workflow for using Docker in production. First thing, as I said, just start with the registry, just do it. Build images, store the images in the registry, tag the images. We're going to talk a bit more about Docker for Dev, Docker for testing, Docker Live. This is sort of the workflow that I recommend. I'm just showing you now, so when I talk, you've got the image. I'm going to show the image at the end. Basically, you're going to push code to your Git repository, whatever. That's going to trigger your build. In Docker, you're going to tag and version that build into your registry. You're going to push that image to testing. You're going to, once it tests, you're going to notify if it completed. If it fails, you hit the developers to say that it failed. They push code again. If it passes, you then push that, re-tag it as this is an image that may go live, and you push that back and deploy it. Pretty much that solves most of your problems. Why I say just keep on re-tagging. I'm sure you've done it with Git. I don't know if you guys do it, but I find it works quite nice. Is you tag releases for testing, and then you tag it. Now this can go live. So when you need to roll back, you can go roll back to the previous live tag, and that's quite nice. So you're not searching through all the tags. You can search for the string which says live when you need to roll back and roll forward quickly.
Just a good convention for.
It's a very one. So I like date and time, and then this is a dev build, this is a testing build, and this is a live build. And then I will re-tag. When I say re-tag, I'll add a tag when I go from testing to live. Once again, so I can very quickly find my live images. It lets you filter a bit better. And you can have one image with multiple tags. It's the same as Git. It follows a very similar process, and they cost nothing. Just start doing this in your build system. You'll start working out what works for you guys. That's just how I prefer doing it. Other guys do versions, or they tag it with the Git commit, part of the hash. It's one of those that depends how your brain works. There is no best way, as long as you're tagging and you have a way of finding what you want. Okay, the registry, the first thing you need to do. This allows you to share your images, make sure everything's running the same. All your dev images should be there as well. I would do my builds on the remote server. Like more, it's like you're building your local PC, you have to push it up, it takes a while. Also now you're forcing you to get commit, pull the Docker file down, build on the remote server. If you're copying Docker files up to the build server, you're doing it wrong. This is the whole thing about code. Like if you manually copy files from your dev PC into the live server to update the website, you're doing it wrong. It's the same pattern you're going to be following. So you commit it. Look, if you're doing tests, you can build on your local system. So normally with this, what I found is normally you're going to have one of the guys building the images. So if you're that guy and you're building and testing, and build them on your thing and test, and once they're ready, you're going to commit the Docker file, pull it down, build on the license type and that's the better pattern. Then doing it remotely is very slow. Use Docker Machine. It's a lot nicer. It's a bit slower on Windows, but it solves the melting files very nicely. They've just released this general release. I've been using it for quite a while. I've stopped using all the other things.
Just one was
Yeah. No, this Docker Machine is installing Docker onto your local PC. And basically, they now bundle the virtual server with it. So they handle all of that for you. So you don't have to install VirtualBox, you don't have to install Fusion. But the big thing, so on Mac they use Windows is Hyper-V. On Mac they use something that it comes with Mac. So it's a lot lighter. But the big thing they wrote a Fuse driver, which is basically like a coded file system driver that you can now mount volumes from your PC in, and then they handle the rights changes. So I don't know if you ever had to, like with Vagrant or VirtualBox, do file system stuff. It gets painful. That's solved. It's not a problem.
So interesting fact about Excel. Excel is actually it's can type 2
I've seen that used by some guy do a Node virtual server, but
it's a lot of
Too many things. Okay. There's two things that you need to run your own registry. Cert and HT password file. If you don't have HT password file for Apache, same file. That's it. You don't need anything extra. You can generate your HT password file this way. Basically, you run the registry saying pipe password into file, pipe another one, you put the certs in the server, you decide where you want the images, and you run that command. Done. You have a registry with passwords and SSL.
Something posted on Slack. Just to
Yeah, I'm gonna that one. I've been looking at it. I only found it yesterday. It looks quite nice. A bit more complicated setup. You still run your own registry underneath. And this will handle. Yeah. So it does the JSON keys. It does all that type of stuff. So if you go right, so the registry is an open source developed documentation of how it works from the Docker guys. So this registry is the one that they built for you. So you run this, but now managing the password file. Doing all that is a bit of a mission, like adding new users, saying these users may pull these images. It does all of that with a nice new GUI. So you can add more users, you can create teams, you can say these teams may pull, these teams may push. Just speed up a bit. Once again, when you build the images, use Ubuntu CentOS when you start, whichever one you're more comfortable, or whatever you're more comfortable with. Tag your stuff in the registry. Like there's an example of a tag. Also have a latest tag just so you know which one to pull. That would be your dev tag. You know, make latest be dev. Don't use that for live or testing. It's not a good idea. Because next thing somebody else pushes one and you're not sure which one to pull. So now this is coming into its a bit more complicated level. So now you want to build your first image to start using it from dev. Okay. You're going to bundle all your tools that the dev has. So if let's say you do MySQL, you have a separate MySQL image. But for like PHP and Nginx, example I use a lot, so another one, you'll bundle those together because they're always tied together. But you're not going to add the code into that one. So this comes back into layers. You build one that does that. So now I'm on my dev server. I run and I mount my Git files into that image running. So as I'm editing, it's changing. Right, the last file edit. If I edit the code there, now, a bit hard to explain. Like when you start playing, this will make sense. Just have an image with the binaries you need and not the code. Because then when you're deving, you can just mount the dev directory. Like, what do you guys mainly code in?
Java, Python.
Okay, so for example, you mount Python directory. You can have your build system be inside the Java, be inside the image, and do the build there. So once again, so you replicate builds. But your editor and stuff will be editing the files on your local PC, and then you'll be committing those to Git. It gives you a consistent dev environment. So like now you don't have to install the same Java version, the same libraries, all that stuff. So you put all your libraries and everything you need in that. So you create that first image. And this is just for dev.
So you're almost deploying your local code into the local image,
yeah.
Right?
So you just, with Docker thing, you have something called volume. So you can say this directory here I want to be put into this namespace. Now it's visible to you and visible to the Docker server. Right? And it just mounts it into, so you put it into directory. So I've got site web that always put my service
So
into.
when the image is running on your local machine and it's you've got it directly and you're editing locally in your local directory, does it? It's the Docker image is seeing those updates, right?
Yeah.
Okay.
So this comes back into the, I think you missed it, I was talking about you should use the new Docker for Mac and Docker for Windows.
Yeah.
Because they've solved that problem. Like that is what it lets you do very easily. Like the big problem is before, you've always been able to do it with Vagrant and all those things, and that's what I was using before. And then I can't remember, there was another one in between that I was using. The big problem is now I have the files in there and I edit them, and then sometimes the writes go a bit haywire because they're not consistent and stuff like that. The Docker machines, now when the writes change, not exactly sure that, but it looks like they store the fact that this thing belongs to web. It doesn't change my writes on my base system. But now when I save, it maintains all of that for me. Look, I also have my Docker machine, when I run it, it fixes any writes problems. just as a safety net as well. But then once I'm running it, it works. It works really. I've got a whole bunch of ones I can show you guys later. Let's do that afterwards. I'll show you how I'm doing it. As I was saying, part of this is building this dev things. You're now making developers' lives simpler. You can have guys who know how to set up Java or set up Python or whatever, setting it up, and everybody benefits. And when it breaks on Bob's PC, you find the fix, you commit it, everyone gets the fix. I don't know how many times I have to go around to different people's Macs, fixing library changes as things updated and stuff like that. And you've got to do it to every single guy because sometimes telling guys how to do it, it's complicated stuff. You tend not to have everyone being able to do it.
And just a quick one about you saying like you have a container or image that runs Java or JDK.
Yeah.
So just say I've got an application that runs on Tomcat. So I create a base image that's Java and from Java and install Tomcat.
I would install Tomcat. So I tend to, like your servers don't change that much. So I'll have Tomcat and the Java in one image. But things that are always tied together, just tie them together. Like they always say separate as much as you can, but like databases are always super separate. Anything that you would move onto a separate PC, separate. Anything you would run always on the same PC. So Tomcat and Java, you'll always have on the same PC. Right. I then won't commit the libraries, the Java.
The WAR files or whatever.
Yeah, I'm going to commit those. Look, unless there's a library you guys always use, but like when you're deving, stuff you would dev, I would keep out. You know, solve this. Like I'm sorry, I don't use Java enough to know.
So Tomcat has a web apps directory, right? Would you create a separate container then with the web apps directory?
Okay. When I start testing and stuff,
Yeah.
when I'm deving, I'll just mount the one from my local PC. If that's the bit that's changing all the time.
Yes.
That's the one I would mount from my local PC because I always want to be deving against the latest version of that.
Okay, so you wouldn't create an extra container. It's still your Tomcat Java container, but it's referencing that local.
Yeah, so when you run your referencing, I'm going to be talking about now when you go to testing. And there I'll take that same image that your dev guys are using. Now I add the code and I tag it. So now I'll get the version, everything bundled together.
Okay.
The problem with deving is normally it's too rapid. You don't want to be like creating images every single time.
Yes.
It gets way too slow. So you want to be able to test with the libraries as close to live. So the things that change and break, you want to have everyone have the same. And then now when you go testing, you now take the same. Remember, you can just add onto an image all the time. Take the same image that the dev guys are using, and you add your libraries in. And you push that to testing. And once testing done, you don't build a new image. You use the same image and retag it for live. Why? Because that's exactly what you tested.
Yeah.
Where a lot of guys will see that, oh, we'll build one for testing and then we'll build another one for live. Now you've broken the immutability. Those are different images. And so you're actually running something different. Look, it shouldn't change, but sometimes, now that I'm running and I pull this update for something from some repository, the version has changed over and I'm just not aware. There are ways of fixing that, but don't make your lives hard. Most of the stuff to talk about. Okay, so I'm going through this quickly, just jumping ahead. This is the bit I'm not sure because this changes depends how the guys can use stock and stuff like that. So this is the bit. So okay, so we've spoken about in dev. You've got these images that your guys pull down. If you really fancy, like I remember that there was like a script that people ran to pull new versions of the images down. Once again, it reduces the guys knowing how everything works. Start looking at composer files at that point, because once again it simplifies what the guys need to know. They don't need to know how to do the run command with the reports and everything and mount the directories and all that kind of stuff. The guys who are more advanced can fiddle with it if they need to. But this is also like onboarding new people and stuff like that. So they come in, you install Docker machine, you give them the composer files, you add the password to the registry, run the composer file, pulls everything down, and they're ready. Right. Then they just need to add editors and get right. It's very quick to pull new guys in. Also, now you fix something, you shout out to the team or send a Slack message, hi everyone, just pull a new version that fixes this. Like, no one needs to compile anything, no one needs to put anything down, you tested it, when it breaks, you can, because it's versioned, once again. Oh wait, that one breaks for half the team, like everyone just use the old one quickly while we sort this out. Okay. It's really on their PCs. It takes a couple seconds to switch. Like these weird things of repeatability. You still have one guy doing that work, but you now don't have the guy doing the work on 20 pieces. Or everyone now doing that work, which happens quite often. So you're now reducing, you don't do any more work, but one person's work can benefit a whole bunch of people. It's the whole thing about amplification of what you can do. As I was saying, now you go to live. Okay, once again, you take the same image that you've tested on dev or whatever, you create a new Docker file that says use this image as base. I'm going to then check out the code, build whatever added to this image, retag it as testing. There's testing 3, and then I deploy that to my testing service. And I run through my tests. Some people, this is live already. I don't test when I test it live. It all depends. Like, it sounds funny. I don't always think that's a bad thing. Like, I think a lot of the rules that people have around this stuff is built for teams that are larger. If you're in a small team, you don't always have time to have all these stages. Cost for developers is quite exceptional. As soon as you have a team of more than 5 or 6, though, like, the benefits start to come in. Like your team's big enough to do testing and stuff. So this is live. Once it's gone through testing, once you're ready, don't automate this deployment. Have a human decide. Okay, very important. Never ever automatically go to live if you can. Like, automate the whole process. Have a big red button. Right? Yes, definitely. Like, that's one thing I firmly believe in. Don't run scripts to deploy to live. You want a button. Once again, repeatability. If I push the button, there's code underneath. I know exactly how it's going to run. I'm not half asleep and I add a tab and something breaks. Okay. Once again, like, you'd be surprised how many errors that removes if you have that. You still want a human there pushing the button. So when it breaks, if something goes wrong, they've also just put a bit of thought into, is this okay? Have a button directly underneath it that says roll back. Like, you've got versions, you know what the previous version was working. Once again, have those as buttons, have a human be able to do that.
The whole run deck.
Yeah, so if you run deck or anything like that. So what I mean is, like, don't go Ansible playbook space, whatever. have a web interface. Like, a lot of server guys are very anti-web interfaces and all the rest of it. Like, you control the scripts. Like, I do believe that. You don't have magic scripts running. You control the scripts. Have it so that a web guy can do the deployment. Not because you're wanting to do the deployment, because that means somebody else comes in, reduces bus factor, reduces human. How many people here have been on a server and run a command and then suddenly realize they ran the wrong syntax? If you work with a server and you haven't put up your hand up, now you're lying. You've all done it. I still remember once I was setting up a new server for something, there was a script that deployed it. And you went in and you ran fdisk and you copied the image and you overwrote the server with it.
I think the worst one is when you're doing T-Box with
No, wait. SSH into the server because you boot off a CD. Did the fdisk, same on PC. After I looked at it, it's like, SSH didn't go through. So, like, you know what I mean? If there was a web interface doing that, it would never have happened. Like, and we didn't accidentally wipe our DNS records. Like, of anything, you can just do that with what you're doing now, and you'll actually be surprised the time savings and the errors you reduce. Okay, right, that's the basics, how to do deployment, how I recommend it. Later on, you'll get into more fancy stuff that you have swarms and things going on. Don't start there. Some future things to look at is the scaling, clustering system, so this Kubernetes, the new swarm stuff, Mesos. Start looking at them once you get further along and you know what the benefits are. Not everyone needs them. This is the weird thing. Like, everyone thinks they need everything. They add complexity. If you don't need the complexity, if you don't need MongoDB running a multi-clustered server, don't go to MongoDB. Like, it must solve a pain point. It's very nice things about Mongo. Like, for web interfaces, it makes a lot of things really, really easy. Especially I find when I'm trying to do like heavy data manipulation, I find it slow and more cumbersome than SQL. Everything has trade-offs. Everything has benefits. Mongo is easy to replicate. I'm just giving that as an example.
So, sorry, just
Yeah.
So, with that whole mindset now that we're going into where servers are cattle on heads, how do you actually decide what to Dockerize and what not?
Everything. Everything except
Well,
DBs. No, but that's the thing. When I deploy a new server,
Yeah.
I spin up a new server, I install Docker. After that, my install scripts, look, it is SSH keys, it does the updates. You know, all the base system stuff that needs to be done is there. Literally after that, any applications that I deploy, Apache, whatever, it's done Docker. Why? It's so much, like, once something, it's way easier than using any of those things. I can, in a couple of seconds, pull the same version onto another server. Like, if I need to keep...
doing config management.
Yeah, so now as opposed to when this deploy was just installed, and I've had to, my big problem was, okay, in this case it's large files involved, it's video files. The biggest problem was getting the files on the new server. I didn't worry about the streaming software, the web servers, any of that, the database. Look, I had backed up and restored the database, but that I had backups going anyway. Like, restoring the actual base system with all the applications took me 5 minutes, right? How many people have built a new server from scratch where it takes them, okay, maybe like 20 minutes, but that's just because from here South Africa doing Ansible to Ansible do updates. I'll do a demo for the guys who want afterwards showing you the new Swarm. I can configure a 5-node Swarm cluster with Elasticsearch installed in about 20 minutes from no servers. So I did a thing. I'll show you. It's scary what you can do now with Docker stuff. Docker Cloud is something else to look at. You guys might not. You guys are maybe the wrong size and stuff. So this is now. I don't want to do my own registry. I want a basic GUI to do deployment and stuff like that with stuff. You can look at Docker Cloud as well. Stuff that they pay for, or it's paid for in the portion. Like all these, okay, not all paid for, but that's one. Just always think it depends on the size of your team. If you've got 4 or 5 guys, right, paying 1,000 Rand for a service is cheap compared to think. You know, if you're hiring one developer like it ranges, like 1 or 2 hours of them spending any time on that a month pays for the service. Like when you guys are bigger, the sums change. So you're running all the stuff yourself, you can get multipliers out of it. In your smaller team, it's paying for stuff is actually cheaper. It's like a very weird thing. I'm still getting my head around it. So I like doing everything myself. But you know, who here would like to run their own mail server? Okay, who here has ever run their own mail server? I never, ever want to do it again. It is the most painful thing that, yeah, never. I will pay someone happily to do it. Just the amount of hours of finding spam and stuff. And being put on spam list accidentally. Yeah. Right, so this comes back into that image I showed you. So it should hopefully make a bit more sense. Push to Git, do your build, push into your registry, from registry to testing onto your live servers. Those live and testing servers can be in the same cluster if you want. Once again, notify that it's okay, have a human sitting there that says, okay, make it live or not, retag it. It's quite a simple pattern. It is actually that simple. It's weird this thing simplifies a bunch of stuff. This thing, something else I'm going to add there. I'll do it just now. Okay, final questions. I'll be around for the guys who want to answer harder questions afterwards.
Or you're distributed keystones, so you're using etcd or console or something else?
I'm not using one right now. Before I used etcd, if I had to pick on a stream, pick etcd. I love HashiCorp. Terraform, if you haven't played with it, if you're doing any cloud stuff, is really scary nice. It's going to show some people. But I think XZD has a lot. Google's trying to make it really good, I think, because I think it's going to work. HashiCorp does some nice things with replicating between data centers, but you can write it yourself. It's fairly simple. You can even at the end of the day use something like RethinkDB if you want to manage it with data centers.
Plot mapping, plot numbers to be tracked with that.
Yes, yeah, no, XZD is a nice one. Like, you know, what I'm saying is, you could, really, if you want, you could, if you have a central database, use on the database. But once again, don't always pick the fancy way of doing it. Like I would use, personally would use etc. and all those, but of course I'm playing more with clustering stuff where even the database is standing up now. And then you need something like that. So you deploy a cluster and you put etc. on all of it. With aiming not to add more than 7 masters, which would be 5 is a better one. Just the way the replication works. Like I made a mistake and that's really important. You want to limit the amount of masters and then the others are all proxies. But have a proxy in every single service. You always speak to the local server for etc. stuff.
HA proxy from the criteria, and then answer just small.
Thank you for asking. Let's chat about the software, so I understand the question better. What everyone's going to about this. But then I can also go into more detail. Any other questions? Right.
Well, I got some from Kieran in Cape Town. He's watching on the streaming. Network-related questions. You want to know if you had, if you can talk a little bit more about the networking stuff. He wants to know which VPN tech you've used, layer 2, layer 3, proxy ARP, anything like that, with Docker.
I haven't used all that stuff with Docker. I've used a couple of those things actually. Right now, there's a whole bunch of different ones to use. My favorite one is actually the new Docker Swarm stuff. Because it just works horribly easy. It doesn't do cross data center stuff, it's not designed for that. But then you can tie them into whatever the VPN stuff. With the new Docker stuff, with the new networking, so like to get the networking that's built into Docker, you need to have a Swarm. Just because so they know what's where. They've actually managed to tie those things into the Cisco stuff, and they'll actually speak to Cisco and create some of the networks for you. If you just use the native stuff, it will also you can make it secure, so that even across the communication between servers is secured, that it does encrypt it. They've done some very scary stuff where they actually do a whole CA built in for you. They do key rotations every 30 minutes for you now. They do a whole bunch of really, really nice stuff. Look, obviously you get a cost because you are, I think they use VXLAN underneath. Also do load balancing on top, so they've got for Linux VIP load balancing. So if you start 3 nodes, and you've got a cluster of 10, if you hit any of the servers on the IP you've mounted, it will load balance to one of those 3. They have all of that for you. It's like magic. They've got like built-in DNS round robin, so you can look up the DNS for that. Like if I had to play, that's my first one. It all depends where you are. This is not talking about more open data centers where other people's stuff would come in.
Okay.
You guys got your own data centers. You can secure stuff separately.
Redundancy, so you got instead of web apps in each data center, you single engine one. So yeah, this data center blows out.
Yeah, no, but I'm talking about more like in the networking where like you guys have access to the switches yourselves, and you've got all that. So.
Sort of, kind of. So the thing is, our reach as our team stops at infrastructure.
Yeah.
Network is another team somewhere, and often we work at different places.
Okay.
And
my favorite VPN software right now, but I haven't tested it at high load, is something called Tink.
yeah, we've used it also.
And I've been using that for like a whole bunch of servers and stuff behind routes that I can get to, and it just
it's mesh networking, right?
It will do shortest path routing and stuff for you.
And you've used it in a Docker environment, or
no, I haven't played to that level.
Okay.
Like, recently, we have been playing with Dockers more on cloud servers, and the virtual network is the backend network. So they've gone in and secured that for me. Look, I've done with the new Swarm stuff. Right. So how they actually do is they create a network layer automatically spanning all your servers in the cluster. So this is one data center. So let's say 10 servers. There's one there. So remember I told you you now publicly expose the port 80.
Okay.
That's on that one, right? Then you can create as many like virtual networks as you want, and you can say, okay, well I want to spin up one application which is a database and these 3 front ends. I want to put them onto their own private network. Okay, and then I'm going to have the applications exposed there. So then what it does is it will load balance from that network to these 3 on a separate. Like it's very hard to explain this stuff from here. But they've actually solved a couple of these problems. It's really nice what they've done.
And if you got layer 2 between your data centers, then you could
Yeah.
actually go
You
cross
can do
data
that. So
centers.
that the new Swarm networking, like this is saying you go to Swarm, it can actually do VLANs. You can say that these 3 servers get exposed to this VLAN and attach it to the other side of that.
Okay.
So you can do it. Look, you've obviously got all the normal routing you have.
Yeah.
And you can do VPNs and stuff like that. It's like on a harder level thing, but it is very solvable. This guy's solving it. Look, they've even run, like as I said, that networking. So you remember you're running Docker commands to create the network. You can
Yeah.
have it that VLAN, that thing will auto add VLAN. They've even had it that it will actually then speak to the Cisco switch and create virtual networks for you between your different servers. Like I had the guys talking, like I've never done it, haven't seen it, but he was talking about like it's on that level. So they're working more and more. Like they've said their main mission is to reduce a lot of the complex stuff for like developers and stuff. Like you just want to have a network. Docker won't create network. You don't have a network. Like you have a network engineer in the back end wiring it up, but you don't have it every time I create something new that you have a network engineer that has to do it. Like your big cost of all this stuff, especially high throughput. You know, you're adding VXLAN, you add an extra header on, so you lose, I guess, 5%. And then you add encryption on, and you lose another. So, like, it depends what you're trying to do. If I know what you're trying to do, I can maybe then advise you a bit better.
I will chat.
Right. Cool. Let's call it that. Anybody who has other questions and wants to see the Swarm stuff? Yeah, we'll chat. Just I think they're getting on the more technical stuff than I want to mention.
Any used Docker on a Raspberry Pi?
No, but it's more time issue nowadays. I've forbidden myself buying the new Raspberry Pi because they have the other 2 and they're sitting in a drawer and I haven't touched them. And I'm grumpy that I haven't touched them because there's stuff I don't play with, but the guys have played, it's very nice. With the new Docker for Mac and Docker for Windows, you can actually run the Raspberry images on your Mac and they do a translation. So you can run, remember it's written for a different kernel. It will actually do the virtualization of the kernel thing for you, so you can do deving on your nice big fast PC. I haven't done it, but I know you can do it. So there are guys who've done that. My biggest pain was this is I had a server that somebody just randomly gave me. I spun it up, I was trying to get something Docker running on it, and I just couldn't get it to damn well work. After some 3 hours, I suddenly realized this is a 32-bit PC. And being Ubuntu, it will install Docker on a 32-bit PC. But not a single one of my images are 32-bit images. I got upset and I didn't throw it, I gave it away to somebody else. It's like, yeah, so it's more time. But apparently it works really well. It's a good place to test. It's a cheap server to test.
We've got about 3 Pis. I'm using fleets and we trust it. I did a lot of it. It's not easy.
I am also going to, I have my own server rack at home with servers in it that I can play with. Why? Because why not? Yeah. Somebody gave it away for free, so I was like, yes! So that's why I was like, I have less need for Raspberry Pi.
Washing machine out. Dragging.
Convinced still life. Cool. Right. Cool. Thank you guys.
Thank you very much, Tim.
There is coffee and donuts.
Thanks, man.